If you asked me the most fundamental way to solve an equation, I would say invert and reverse. In this video, we are only going to solve equations that have one variable and one solution. There are, of course, other types of equations and other techniques to solve them, but you need to understand this first. I'll explain what invert and reverse means as we go through the examples, and you can skip to that, but make sure that you are aware of all the algebraic operations and their inverses. So after you learn how to count, the next thing you learn how to do with numbers is, well, add them. And then once you've got that figured out, we teach you the inverse of addition, which is subtraction, right? So addition and subtraction are inverses. Note, I'm not calling them opposites. The proper word here is inverse. After this, you learn the next pair of inverses, multiplication and division. So these four operations right here make up arithmetic. Next, we'll extend into algebra, right? So the next thing you learn that you can do with numbers is powers. And so this would be like x to the second power, x to the 10th power, just some sort of positive integer exponent makes it a power. And then the inverse of a power function is a root. So the inverse of the second power would be the second root. The 10th power would be the 10th root. And I've given you here the two different ways we could write roots. In this video, I will stick with using the radical sign, but you can swap it to a rational exponent if you want. After that, we learn about exponentials. So what's the difference between an exponential and a power? It's where the variable is. So if you notice in the power expression here, the variable is in the base, but for the exponential, the variable is in the exponent. So that is the difference. And then, okay, what is the inverse of an exponential, right? This is what a logarithm is. Now, I know logarithm, that word sounds intimidating, it sounds confusing, but all it is, it's the inverse to an exponential, just like division is the inverse of multiplication. It's the same relationship. Good. So these 8 operations right here, paired in their inverses with their inverses, make up algebra. These are the 8 operations you need to be able to work with for high school or college algebra. Now, I'm going to go ahead and throw down 2 trigonometric functions. You don't have to worry about it. Only one of the examples in this video uses trig, but just to help you see the big picture. In trig, we use this function called the sine function, and the inverse of sine is sometimes called arcsine, A-R-C-S-I-N-E, or you could take the more literal route, which is what I prefer, and just call the inverse sine. And we write this with a little -1. Now that -1 looks like an exponent, but it's not. It just means inverse. And we'll do the same thing with cosine here. Good. So again, just for algebra, you only need the top 8. Of the 15 examples that we do in this video, only the last one has trigonometry. So here's the first equation, 2x plus 3 equals 11. That 2x right there, that means 2 times x. This will never be presented to you with a multiplication dot, but here it is for now. That's what that means. So the question that we are trying to answer is 2 times what plus 3 is 11. And you might be able to do this in your head, right? Can you think of a number that when I multiply it by 2 and then I add 3 to it, I get 11, right? But let's go ahead and walk through the process here. Here's a way that you may have never visualized this before. So according to this equation, we start with some mystery number, some unknown, right? And if we take that number, whatever it may be, and we multiply it by 2, and then we add 3 to it, we will end up with 11. So how do we solve this? How do we figure this out? Well, invert and reverse. So here's what I mean by that. This equation multiplies and then adds. So what are we going to do? We are going to subtract and then divide, right? Reverse order with the inverse operations, right? The inverse of a plus 3 is a minus 3. That's the first thing we need to do. And then the inverse of a times 2 is a divided by 2. And that's the second thing that we will do. And that will give us the answer. So let's run it. 11 minus 3 is 8. And 8 divided by 2 is 4. That's the answer. Let's check it. 4 times 2 is 8, plus 3 is 11. 11 minus 3 is 8, divided by 2 is 4, right? So it's just this forward and backwards motion, feeling, right? That's the invert and reverse. But here's how you would actually do this on your quiz, on your exam, right? You're given this equation. The first thing we did is we subtracted 3, right? So we subtract 3 from both sides. That cancels out the 3's on the left, bring everything down, evaluate 11 minus 3, which is 8. All right, that's the first thing. And then the second thing that we did was divide by 2. So we divide both sides by 2. That cancels out the 2 on the left. Bring down everything else, evaluate. 8 divided by 2 is 4, and that's the answer. So this is very detailed. As the examples go on, my animation skills got a little bit better, so we'll have more concise work. But that's the idea. That really is the most fundamental idea behind solving equations. Apply the inverse operations in reverse order. Here is example 2. So this is 3 times x minus 7 equals -6, right? And that 3 right up against the parenthesis, that does mean multiplication, right? So again, these are things that will not be explicitly written, need to be understood. So that's 3 times right there. So the question we are trying to answer is, what minus 7 times 3 is -6? And again, you may be able to think of that in your head, but here is the proper way. So according to this equation, we start with some number that we have yet to discover. The first thing that happens is we subtract 7 from that number, and then that is multiplied by 3, and the result is a -6. So let's invert and reverse. The inverse of multiplying by 3 is dividing by 3, and the inverse of subtracting 7 is adding 7. So if we do those two things, we will get the answer. -6 divided by 3, what is that? What is -6 divided by 3? That is -2 plus 7. What is -2 plus 7? That is the same thing as 7 minus 2. And that right there, that is going to be 5, right? The answer is 5. Let's check it. So 5 minus 7 is -2 times 3 is -6. -6 divided by 3 is -2 plus 7 is 5. So that's the full circle there. But how would you write this out in class? Here's the equation. Now, you've probably been taught to distribute the 3, and that is not wrong. However, it adds at least one extra step, just one extra step, I believe. So if you want to be as efficient as possible, I would divide both sides by 3 first, cancel out the 3's on the left, bring everything else down, evaluate -6 divided by 3, which is -2. All right, the second thing we did there was add 7 to both sides, cancel out the 7's on the left, bring everything down, evaluate -2 plus 7 is 5, and that right there is the answer. Example 3 here has subtraction and division, right? Anytime you have a fraction bar like that, that implies division. So the question we are trying to answer is, what minus 21 divided by 5 is -3? Let's go ahead and set this up. According to this equation, if we start with some number and subtract 21 from it, and then divide that by 5, the result will be -3. So let's invert and reverse. The inverse of dividing by 5 is multiplying by 5, and the inverse of subtracting 21 is adding 21. So those are the two things we need to do. -3 times 5. What is -3 times 5? That is going to be -15. And then what is -15 plus 21, right? That's the same thing as 21 minus 15, which is going to be 6, positive 6. Let's check our answer. 6 minus 21 is -15, divided by 5 is -3. And then -3 times 5 is -15, plus 21 is 6. how would you write this out? We'll start by multiplying both sides by 5. And so that'll cancel out the 5s on the left. Bring everything else down. X minus 21 equals negative 3 times 5. Evaluate. Negative 3 times 5 is negative 15 right there. Good. And then we add 21 to both sides, canceling them out on the left. Bring everything down and evaluate, which gives us the answer of 6. So right here, this is the more efficient work I was alluding to. This is great. You write that down on your quiz or exam, you'll be golden. Example 4 here, x divided by 2 plus 13 equals 9. So the question we are trying to answer is, what divided by 2 plus 13 is 9? And try that in your head, right? Can you think of that number? But let's go ahead and unravel it. According to this equation, we start with this number, we divide it by 2, we add 13 to that, and the result is 9. So to solve, we're going to invert and reverse. The inverse of plus 13 is minus 13, and the inverse of divided by 2 is times 2 multiplied by 2, and that'll get us the answer. So let's do it. 9 minus 13. All right, what's 9 minus 13? It's going to be negative. That's negative 4. Times 2 is negative 8. And that's the answer. Let's check it. Negative 8 divided by 2 is negative 4, plus 13 is 9. 9 minus 13 is negative 4, times 2 is negative 8. Here's how you would write this out. The first thing we did was subtract 13 from both sides. Cancel out the 13s on the left, bring everything else down. Evaluate. 9 minus 13 is negative 4. Then multiply both sides by 2. Cancel out the 2's on the left, bring everything down. Evaluate. Negative 4 times 2 is negative 8, and that right there is the answer. Here's example 5, and things are getting a little interesting now. So we have multiplication, but we have a power this time. So this reads 5x cubed equals 40. The question we're trying to answer is, what cubed times 5 is 40? So this word right here, cubed, that's a special word for the third power. So we could say what to the third power times 5 is 40, but the most efficient way to say this is cubed. Cube means the third power. So let's set this up. According to this equation, we start with some number. If we start with some number and we cube it, and then we multiply it by 5, we will end up with 40. So even though we are working with a new operation here, the principle is the same. Invert and reverse. The inverse of times 5 is divided by 5. And then the inverse of the cube, which is the third power, will be the third root, which we can call the cube root. So the inverse of the cube is the cube root. That is a radical symbol with a little 3 right there, and that will return us to the original number. So 40 divided by 5, what's 40 divided by 5? That's 8. And then the cube root of 8, what's the cube root of 8? In other words, what to the third power would give you 8? And that's going to be 2. The answer here is 2. Let's check it. 2 cubed is 8, times 5 is 40. 40 divided by 5 is 8, and the cube root of 8 is 2. So that's the whole thing right there. How would you write this out? So if you had this equation on your paper, you would first divide both sides by 5, cancel out the 5's on the left, bring everything down, evaluate 40 divided by 5, which is 8, and then you would cube root both sides, just like this. This is what it would look like. Cube root both sides. The cube root and the cube would cancel out, not the x. I did not cross out the x. Bring down the x and everything else. Evaluate the cube root of 8, which is 2, and that right there is the answer. Example 6, we have the square root of x plus 4 equals 9. So the question we are trying to answer is the square root of what plus 4 is 9, right? So, all right, let's talk about that square root right there. You remember in the last example, we had a cube root. We had that symbol with a little 3 up on top of it. That's called the index. When there isn't a number there, it is implied to be a 2. And the 2, whenever you have a second root or a second power, we use the word square. So this is the square root, and when we invert that, we will call it the square. So anyways, let's set this up. We take some number here. According to this equation, if we square root it and then we add 4 to it, we end up with 9. So let's invert and reverse. The inverse of plus 4 is minus 4, and the inverse of the square root is the square, or the second power. So there's your 2 right there, and that will get us the answer. So 9 minus 4 is 5, and then 5 squared, that means 5 times 5, which is 25. Let's check it. Start with 25. If we square root that, we have 5, and then add 4, that's 9. 9 minus 4 is 5. 5 squared is 25. So that checks out. Here's how you would write this. Start by subtracting 4 from both sides. Cancel out the 4s on the left. Bring everything else down. Evaluate 9 minus 4, which is 5. To get rid of the square root, the inverse is the square, right? The power of 2, second power. Do that to both sides. That cancels out. Bring down the x. The 5 squared, 5 times 5 is 25, and that's the answer. Example 7 here has an exponential, right? You see that variable x is the exponent. That's what makes it exponential as opposed to a power. So this reads 3 to the x minus 8 equals 1. As a question, we're trying to answer 3 to the power of what minus 8 is 1. So let's unravel that. Bring down that x, right? According to this equation, we start with some number, and if we exponentiate it with a base of 3, and then subtract 8 from that, we will end up with a 1. So let's invert and reverse. The inverse of minus 8 is plus 8. All right, remind me, what is the inverse of an exponential? Right, the word for that is a logarithm. That's what logarithms are. They are the inverse of exponentials. So we also have to match the base. So the inverse of exponential base 3 is logarithm base 3. And that will get us the answer. So good, 1 plus 8, that is 9, and then log base 3 of 9, right? That is asking you 3 to the power of what is 9? And that is 2. Let's check it. 2 exponentiated base 3 is 9, minus 8 is 1. 1 plus 8 is 9, log base 3 of 9 is 2. Right, so it checks out. That works good. Here's how you would write this out. So here's your equation. You start by adding 8 to both sides, cancel out the 8's on the left, bring everything down, evaluate. Good. At this point, you are going to take the logarithm base 3 of both sides. The log base 3 will cancel out with the exponential base 3. Bring everything else down, evaluates log base 3 of 9, which is 2. And that's the answer. Example 8 with a logarithm base 6 and division dividing by 2 here. So this reads log base 6 of x divided by 2 equals 1. As a question, we're trying to answer log base 6 of what divided by 2 is 1. So we start with some number here that we don't know what it is yet. We call it x. If we pass that through the log base 6 and then divide that by 2, according to this equation, we'll end up with a 1. So let's invert and reverse. The inverse of dividing by 2 is multiplying by 2. And the inverse of logarithm base 6 is exponential base 6. 1 times 2 is 2. Exponentiated base 6 is 36. Let's check it. Log base 6 of 36 is 2. Divided by 2 is 1. 1 times 2 is 2. Exponentiated base 6 is 36. Here's how we write this out. Start by multiplying both sides by 2. The 2's cancel out. Bring everything else down. Evaluate. Good. At this point, your teacher, instructor, professor has probably taught you to rewrite this in exponential form. That is the correct thing to do. I'm going to stick with my theme here, but the result is the same. To cancel out that logarithm base 6, I need to exponentiate both sides, base 6. The exponential cancels out with the logarithm, bring everything down. Like I said, this is what your teacher will teach you to write next anyways. X equals 2 exponentiated base 6, which is 36. That's the answer. Up until this point, all of the examples have been two-step equations, literally meaning they take 2 steps to solve. So this example and the 4 that follow, so the next 5, this one included, are going to be 3-step equations. But again, the principle is the same. We're going to invert and reverse, but they'll just be 3 operations. So this equation right here is asking us, what plus 9 times 8 minus 10 is 30. So that's what we're trying to solve. So that is, we start with some number x, and according to this equation, if we add 9 to it, and then multiply by 8, and then subtract 10, we will end up with 30. So let's go ahead and invert and reverse. The inverse of minus 10 is plus 10. The inverse of times 8 is divided by 8. And the inverse of plus 9 is minus 9. That will solve this. So 30 plus 10 is 40. 40 divided by 8 is 5. And 5 minus 9. What is 5 minus 9? It's going to be negative. That is -4, and that is the answer. Let's check it. -4 plus 9 is 5, times 8 is 40, minus 10 is 30. 30 plus 10 is 40, divided by 8 is 5, minus 9 is -4. So full circle, it still works, invert and reverse, just with 3 operations. Here's how you would write this out. Now, again, I've addressed this in this video before. You probably have been taught at some point to distribute the 8, and then you would combine like terms. Now, again, that is not wrong, but if you go straight with inverting and reversing, you will get to the answer just a little bit faster. So the most efficient thing to do here is to start by adding 10 to both sides, cancel those out, bring everything down, evaluate 30 plus 10, which is 40. Step 2, divide both sides by 8, cancel those 8s out, bring everything down, evaluate 40 divided by 8, which is 5. Step 3, subtract 9 from both sides, cancel, bring it down, evaluate. The answer is -4. Example 10 says 4x minus 7 over 11 equals 3. As a question, we are trying to answer what times 4 minus 7 divided by 11 is 3. So let's set this up. According to this equation, if we start with some number x, multiply it by 4, then subtract 7, and then divide by 11, the result is 3. Let's invert and reverse. The inverse of dividing by 11 is multiplying by 11. The inverse of minus 7 is plus 7, and the inverse of times 4 is divided by 4. 3 times 11 is 33. plus 7 is 40, divided by 4 is 10, and that's the answer. Let's check it. 10 times 4 is 40, minus 7 is 33, divided by 11 is 3. 3 times 11 is 33, plus 7 is 40, divided by 4 is 10. Here's how you would write this out. Start by multiplying both sides by 11. Cancel out the 11s, bring everything else down. Evaluate. 3 times 11 is 33. Step 2, add 7 to both sides. Cancel the 7s, bring everything down. Evaluate 33 plus 7, which is 40. Step 3, divide both sides by 4. Cancel the 4s out, bring it down. Evaluate 40 divided by 4, which is 10. And that is the answer. Example 11 here has multiplication, a root, and addition, right? Same with parentheses. When you have a number up against parentheses, that implies multiplication. When you have this number right up against the root, that also implies multiplication. So this reads 5 times the square root of x plus 2 equals 15. As a question, we might ask the square root of what plus 2 times 5 is 15. Now, you may have noticed that in some of these examples, the order of operations is a little bit ambiguous according to the translation, that is the question. And here that really starts to show. Is that if I just asked you this question without the equation, the order of operations would be unclear. So don't focus too much on being able to translate these equations. By now, you are understanding how to solve them, right? Invert and reverse. So anyways, we start with this number x. If we add 2 to it, and then square root that, and then multiply it by 5, we end up with 15. So let's invert and reverse. The inverse of times 5 is divided by 5. The inverse of the square root is the square, or the second power. And the inverse of plus 2 is minus 2. Let's run that. 15 divided by 5 is 3. 3 squared is 9. 9 minus 2 is 7. That's the answer. Let's check it. 7 plus 2 is 9. The square root of 9 is 3 times 5 is 15. 15 divided by 5 is 3. Squared is 9 minus 2 is 7. Here's how we would write this out. Step 1, divide both sides by 5. The 5's cancel. Bring everything down. Evaluate 15 divided by 5, which is 3. To get rid of the square root, you would square both sides. That cancels out. Bring down the x plus 2 and 3 squared, which is 9. Last step, subtract 2 from both sides. Cancel, bring down. Evaluate 9 minus 2 is 7. That's the answer. Example 12 has an exponential. It has division and it has subtraction. This reads 2 to the x divided by 4 minus 5 equals -1. As a question, we could ask 2 to the what divided by 4 minus 5 is -1. Again, the question alone is a little ambiguous, but we have the equation to follow along with. So let's set this up. We start with some number, x, we don't know what it is yet. And if we exponentiate it, base 2, and then divide that by 4, and then subtract 5, we end up with a -1. So let's invert and reverse. The inverse of minus 5 is plus 5. The inverse of dividing by 4 is multiplying by 4. And the inverse of exponential base 2 is logarithm base 2. Start with -1 plus 5. That's the same thing as 5 minus 1, which is 4. Multiply that by 4 gives us 16. and then we need to take the log base 2 of that. Log base 2 of 16 is 4. That is the answer. Let's check it. 4 exponentiated base 2 is 16, divided by 4 is 4, minus 5 is -1. -1 plus 5 is 4, times 4 is 16, log base 2 of 16 is 4. Here's the work. First step, add 5 to both sides, cancel out the 5s on the left, bring everything down, evaluate, -1 plus 5 is 4. Multiply both sides by 4 is your second step. Cancel out the 4s on the left, bring everything down, evaluate, 4 times 4 is 16. Lastly, to cancel out exponential base 2, we need logarithm base 2. The log cancels out with the exponential on the left, bring down the x equals log base 2 of 16. Evaluate that, 4 is the answer. Example 13 has a logarithm, a power of 3, also known as the cube, and subtraction. So this reads log base 5 of x cubed minus 2 equals 2. As a question, we could ask log base 5 of what cubed minus 2 is 2? That is, according to this equation, we start with some number that we don't yet know. If we cube it, and then subtract 2, and then take log base 5, we will end up with 2. So let's invert and reverse. The inverse of logarithm base 5 is exponential base 5. The inverse of minus 2 is plus 2, and the inverse of the cube is the cube root. 2 exponentiated base 5 is 25. Plus 2 is 27. The cube root of 27, what's that? What do you think that is? That is 3. That's the answer. Let's check it. 3 cubed is 27, minus 2 is 25. Log base 5 of 25 is 2. 2 exponentiated base 5 is 25, plus 2 is 27. Cube root is 3. Here's the work. To cancel out that log base 5, you need to exponentiate both sides, base 5. The exponential cancels out with the logarithm on the left. Bring everything else down. Evaluate 2 exponentiated base 5 is 25. Step 2 is to add 2 to both sides. Cancel out the 2's, bring everything down, evaluate 25 plus 2 is 27. To get rid of the third power, or the cube, we need the third root, or the cube root. Cube root both sides is your third step here. The cube root and the cube cancel out, bring everything else down, evaluate the cube root of 27, which is 3, and that is the answer. All right, here is example 14, and this is the main example of the video. Everything has culminated up to this point so that you can understand how to solve this. Right, so this is a 4-step equation, and we will tackle this one step at a time. We're not going to translate it. Really no point anymore. Let's go ahead and just map it out. So according to this equation, if we start with some number x that we don't yet know, and we subtract 5 from it, and then we exponentiate it base 3, and then multiply it by 4, and then square root it, we end up with 6. So let's invert and reverse. The inverse of the square root is the square, or the second power. The inverse of multiplying by 4 is dividing by 4. The inverse of exponential base 3 is logarithm base 3. And the inverse of minus 5 is plus 5. So let's solve it. Starting with 6 squared. That is 6 times 6, which is 36. Divide that by 4. which is 9. Plug that into logarithm base 3, which is 2. And then add 5, which is 7. And that's the answer right there. Let's go to the work. The first thing you are going to do is cancel out that square root by squaring both sides. The square and the square root cancel out, bring everything else down, evaluate 6 squared, which is 36. Step 2, divide both sides by 4, cancel out the 4s, bring everything else down, evaluate 36 divided by 4, which is 9. Step 3, we need to cancel out that exponential base 3 with a logarithm base 3. Those cancel on the left, bring everything else down, evaluate log base 3 of 9, which is 2. Last step, step 4 here, is to add 5 to both sides. The 5s cancel, bring everything else down, evaluate 2 plus 5, which is 7, and that right there is the answer. So, good. Take a moment here and appreciate what you're looking at. This equation right here utilized all 8 algebraic operations organized in pairs with their inverses. So in blue, we have addition and subtraction. In orange, we have multiplication and division. In pink, we have a root and a power. And in yellow, we have an exponential and a logarithm. If you're able to work with all 8 of these and understand how they're organized according to their inverses, you will do just fine in your class. Keep studying this. As promised, there is one more example in this video with a trigonometric function. It's just a 2-stepper. Stick around and see if you can figure it out. Last example, example 15 here, we have an inverse cosine with a logarithm inside. So as a question, this is asking, inverse cosine of log base 10 of what is 0? So pause real quick here. In yellow, I have log base 10. You say, where's the 10 coming from? This logarithm in the equation doesn't have a base. Well, it doesn't have an explicit base. And when the base is not written, it is implied to be 10. And we call this the common logarithm. So 10 it is. Let's go ahead and map this out. According to this equation, we start with some number. We run that through the common logarithm. Then we take that number and we run it through inverse cosine, and we end up with a 0. So let's invert and reverse. The inverse of inverse cosine is cosine, right? Normal cosine. And the inverse of logarithm base 10, or the common logarithm, is exponential base 10. Here we will actually write the 10. Good. Let's evaluate, starting with cosine of 0. Cosine of 0, if you don't know that, that's okay. It's 1. And then we need to exponentiate that base 10, which is just 10. That's the answer right there. So let's go ahead and just go to the work. I'm going to organize this a little bit differently than I have in the video, just for the sake of space. What you're going to see right now is the x and the equal sign and the 0 are all going to come down and stay on their respective sides. The logarithm is going to come down and stay where it is. However, the inverse cosine is going to switch from the left to the right and turn into a normal cosine. We then evaluate cosine of 0, which is 1. Good. Next step is you're going to see the 1 and the equals and the x come down. The logarithm is going to switch from the left to the right and change from a logarithm base 10 into the exponential base 10. Evaluate 1 exponentiated base 10, which is just 10. That right there is the answer. Cool. Thank you for sticking around. I hope you learned something. We'll see you in the next one.